we're on number 4, page 3 of our Module 4 Lesson 8 notes. So this is something that you would see if you're looking at new house models, apartment models, and they'll show you a scale drawing of the place that you'll be renting or buying. So a marketing brochure shows the floor plan of a kitchen and the dining area below. If the actual length of the kitchen is 10 foot, so this in real life is 10 foot. And notice these are the same, so it doesn't matter whether I put it there or put it here, right? Usually you just call length this and width that, but they're the same, so it doesn't matter. So do you see what our comparison ratio is going to be? 1 1/4 goes with 10 feet, right? And what's the actual length of the dining area? So we want to know what this is in feet. So there's a couple ways we could do this. We could do kitchen over dining equals kitchen over dining, or we could compare feet and inches. I kind of like that way better. So let's do inches, feet. But both answers give you the same, or both problems will give you the same answer. So don't think that one is right and one is not correct. So we have, I'm trying to get everything in at once. Okay, so 1 1/4 inches. It corresponds to a 10-foot kitchen. And then 3/4 inches corresponds to an X foot dining area. So inches to feet, inches to feet. So let's practice our fraction multiplication and division. This is good practice for the final exam because we have lots of fractions on the final exam and you don't get to use a calculator. So this will be good practice. Good thing you just took Module 3 tests though, so it's probably pretty what should I say? Pretty fresh in your head because you just took the test. So this cross product is 1 1/4 times x. This cross product is 10 times 3/4. So we know how to do this. Remember when we learned on the very first day of multiplication of fractions, if one of them is a whole number, just put it over 1. And this eventually is going to have to be improper because it's going to be divided. So let's go ahead and do that on this step. So this is 4 plus 1, 5/4 times x equals 30 over 4. I'll show you how to do this on the calculator after we do it by hand too, because I want to make sure you guys feel comfortable on the calculator going into the next class, so you haven't not picked one up. So you can at least write down the keystrokes or practice on one that you have at home. So we have a fraction that needs to be simplified here. I always try to simplify in the middle of the problem if I can, just to make the number smaller to work with. So this is going to be 15 over 2, because they're both even. Okay, so this is multiplication. So the opposite of multiplication is division, right? So that means to get x alone, I have to divide both sides by 5/4. But we know how to divide fractions, right? Remember that good old keep, change, flip? So I'm going to tell you, this looks super confusing to students. So the first thing I would do, we're kind of out of room, so let's go up here. So we have x equals, and this is the first thing I would do, keep it in the same order and just change it to a division problem. So 15 over 2 divided by 5 over 4. So now you look at it and go, oh, I know how to do that one. But when you see it in this form, not so obvious. So keeping it in the same order, you just change it to a division problem because that's what a fraction bar means, is division. So it's 15 halves divided by 5 fourths. And we learned in Module 3, whenever it's division, we do keep, change, flip. So this would be keep the first fraction, change to multiplication, flip the second fraction, which would be 4 over 5. So then we get 60 over 10, which is 6. So that wasn't so bad, right? It looked ugly there for a moment, but look how nice and easy it worked out. So 15 times 4 is 60, 2 times 5 is 10, 6 divided by 1 is 6, and it's going to be beat. So you want to see how to do that on the calculator? The calculator can do it in about 2 seconds. So we write this step out, so we have it for our calculator. So 1 1/4 times x equals 10 times 3/4. So on our calculator, we type in 10. And remember how I said this is the fraction key? Fraction bar 1, and you don't really have to write that, times 3 fraction bar 4. And it gives us 7.5. And you're probably like, that's not what we got. Well, guess what? It is. Because 7.5 and 15 halves are the same thing. 2 goes into 15 7 times with 1 left over. So it is. So now we're at this step, or maybe this step. So the next step is to take the answer that you got and divide by 5 fourths. So with that still in my screen, I write divided by 5 fraction bar 4. Okay, so I still had this answer in the screen. I just had it written as 7.5, which is fine. Same thing. And then I do divided by 5 fraction bar 4. So see what the answer looks like? Boom. So how fast did that calculator do that? Really fast, right? So yes, that is how you do it on the calculator if Alex offered it to you. If it didn't, then hopefully you'll remember stuff like that for your next class. Okay, so let's do another one. Sometimes this notation confuses students a little bit. See, if I saw this problem on a test, I'd go, oh, of means times the actual train. Well, here's the actual. So I wouldn't even set up a proportion for it, and I'm not sure if the directions said we have to. Use a scale factor, constant ratio, or set up a proportion. So we're supposed to set up a proportion, but really, if you were doing this like you did in Module 3, remember how we learned of means times, and actual train is 40, you could just do 1 over 160 times 40 over 1. But since our directions say set it up, so when it says typically 1/160th of the size, that means the scale to the actual. So when the scale's 1, the actual size is 160, right? Because the scale's going to be the small one, the actual is going to be the large one. So it says, what is the length of the model? Oh, I guess they're calling it a model, not a scale. What is the length of the model if the actual boxcar is 40? So I see something going on here, you guys. So to go towards X, what do? Isn't this divided by 4? Remember how we learned in Module 3 that you could multiply or divide? Well, I'm saying that's divided by 4 because 4 times 4 is 16. So divide this one by 4. So you're probably going, what? Divide 1 by 4? Well, isn't this 1 divided by 4? Yeah. So that's 1 divided by 4 is 1/4. And the scale is, I guess they're both feet, huh? So 1/4 of a foot is your answer. So 1 divided by 4. Could you have done this? Absolutely. Yep, you would have had 160 x equals 40, and your answer would have been 40 over 160. You would have crossed out the zeros and got 4 over 16, which is 1/4 of a foot. So if a real train is 40 feet long, then a model train would be 1/4 of a foot, and 1/4 of a foot is what, 3 inches? 4 into 12 is 3. Yep. They didn't ask us for inches, but still, that's good to know. They gave it all in feet. So that's kind of a tricky little one. That's not usually how you see them written, but okay, let's go to the back. And I can tell we're going to have a short video in the making because we're not going to get both of these done in the next 3 minutes. So I'll have to do a little short video at the end to finish up what we don't get done. So these triangles are similar. That means the sides are proportional. So I like to mark the sides that go together. So 3 goes with 9, and then I mark them all differently. 4 goes with 12. Those are called corresponding sides, and that's important. 5 goes with X. So we only need four sides total. So what I usually do is I look at them and throw out the one with the biggest numbers. We have to keep this one that has our X. 3 and 9 is a little bit smaller, so I'm not going to use these two. I mean, you hit the same answer. I'm just trying to make it a little bit easier. So remember how we can go left to right equals left to right, or you can go left to right equals left to right. Either one gives you the right answer. So I like to keep the colors together. So 3 goes with its corresponding side 9. And if I start with the left triangle, the next fraction has to start with the left triangle too. So 5 with X. So this is kind of like left over right. So left triangle over right triangle, left triangle over right triangle. And you have to make sure they're matched up with their own sides. So we need to be on the lookout for a common ratio. What did they call that? There's scale factor or constant ratio. So a constant ratio. I was calling it the right thing. I didn't think so. So I don't see anything going from here to here, but I see something going from here to here. To get to 9, multiply by 3. So to get to X, multiply by 3. So that means X equals 15. Usually they have inches or feet or something like that on that. This one didn't. That kind of bugs me because I like students to practice with units. And we're out of time on this video, so we'll do the last one on the last video. See you in a bit.